Hello students, welcome to all of you. After successful completion of your unit test, now the time to study a new topic, that is classification of elements belonging to Mendeleev periodic table. But before commencing the next chapter, children, I would like to explain you some of the questions concerned to de Broglie question asked by your class student. So, first know them, then we will study new topic. So, the question which was asked is a question number 2.60, that is of NCERT book, and page number 68. So question is, the velocity associated with a proton moving in a potential difference of 1000 volt is 4 means velocity is given that V is 4.37 into 10 to the power 5 meter per second. 10 to the power 5 meter per second if the hockey ball of mass 0.1 kilogram and mass of the ball is given 0.1 kilogram, that may be written as 10 to the power minus 1 kilogram also. Okay? Then calculate the wavelength associated with this velocity. So no problem, children. Go on the basic. Just utilize the formula. Here in this question, there is no meaning of potential difference. That is the only given for a velocity of electron which is moving with that potential. So there is no utilization of that point. Just go on the basics of de Broglie question and you can easily find. So you are knowing that this lambda is equal to h upon m into b, showing de Broglie equation. Alright. So in this, b and m are known and h value you are already knowing. So no problem, just put the values. So value of Planck constant is 6.6 into 10 to the power minus 34. Value of m is given, that is 0.1, r can be written as 10 to the power minus 1, and into value of b is also given, 4.37 into 10 to the power 5. So listen student, this 10 to the power 5 and 10 to the minus 1 become 10 to the power 4. So this may be written as 6.6 divided by 4.37 I into, listen, if this become 10 to the power 4, if it will go in numerator, become positive, and the value can be written as 10 to the power minus 34 and plus 4. Can be written, children? Okay. So this becomes 6.6 upon 4.37 into 10 to the power minus 30. Can be written? Am I right? 34, sorry, if you will go in numerator, this value will go in numerator, that will still minus, not plus. This is plus, going in numerator, so will be minus. So 34 and minus 4 will be minus 38, children. Alright, and when you solve this value will approximately come 1.51 into 10 to the power minus 38 meter, and that will be perhaps answer. Am I right, children? Okay, so how simple? Don't go on the breadth and length of the question, just go through the formula, go through your concept, then you have no trouble. But don't interfere with calculation. You have to do it. Alright? So this will be the wavelength. Wavelength is asking. So wavelength will be this one. This may be the answer. Second question, and these questions are important. Must remember that may come all time they are asked. So be focus on such type of questions. Next question is 2.60. Just finish them. Question number 2.59 on same page. And question is, the velocity of the electron in Bohr's orbit is 2.19 into 10 to the power 6 meter per second. Means the velocity of the electron in Bohr's orbit is given. So given that the points which are given, note down sincerely, then go on the question which is going to ask. Okay? So given that what? That is V, velocity of the moving electron, is 2.19 into 10 to the power 6 meter per second. Then calculate the de Broglie wavelength associated with it. Okay? Question is, if the velocity of the electron in Bohr's orbit is this one, then calculate the de Broglie wavelength. So you have to find lambda. So utilize same formula as you are knowing. Lambda is h by mv, where lambda is wavelength, h is Planck constant, m is the mass of the particle, and v is the velocity of the particle. So put these values. The value of this Planck constant is, as usual, we are knowing, 6.6 into 10 to the power minus 34 joule second. So 6.6 into 10 to the power minus 34, and mass of electron you are knowing, and that value is what? That value is 9.1 into 10 to the power minus 31, and V is also given, student. Put this V into 2.19 into 10 to the power 6. Once again, arrange the powers which are looking together. So listen, here 10 to the power minus 31, here 10 to the power 6. This is in minus sign, this is in plus sign. So if you deduct minus 31 and plus 6, the value will perhaps come 10 to the power minus 25 here. Children, listen, this minus 31 and this 10 to the power 6. Powers are same. You are knowing that formula a to the power m into a to the power n is a to the power m plus n. So using simple formula, so minus 31 plus 6 may be 10 to the power minus 25. Am I right? Okay. So this can be written as 6.6 into 10 to the power minus 34 divided by 9.1 into 2.91. I into, children, the value which is coming 10 to the power minus 25 by these powers. If that will go in numerator, it will become positive and may be written as. Can be written, children, in the same 10 to the power minus 34 plus 10 to the power 25. If this is in minus, going in numerator, become plus, and the symbol will be here. And now what? That is 34 and 25, perhaps 9. Am I right? So on solving this very point, the value may actually come 0.332 I into 10 to the power minus 9 meter, because we are finding lambda, and you are knowing that, children, 10 to the power minus 9 meter is 1 nanometer. So this may be also written as 0.332 into 10 into nanometer, because 10 to the power minus 9 meter is equal to 1 nanometer. So this can be written as 0.332 nanometer. And children, one more thing, if the question is asking in picometer, then no problem. This 0.332, listen, 0.332 can be written as 332 into 10 to the power minus 3 into 10 to the power minus 9. Children, can be written. I just removing the decimal by power. Just removing the decimal by power. So it become what? Minus 9 and minus 3 minus 12. And you are knowing 332 into 10 to the power minus 12 meter, that is equal to picometer, because 1 picometer is 10 to the power minus 12 meter. So this will be in picometer. If in picometer this will come, in nanometer this will come, in meter this will come. So all the options are here. As you want to find out, you have utilized a proper unit. So this may be the probable answer of this very question. Children, how simple? Have I done anything? Good reply. No. That is all done by you. Well, next question, one more, children. That is question number 2.57. This question is also looks like breadth and length is just looking much, but its solution is very simple. And question number 2.57. Next question is 2.57c. Just see, children. Time is running. We have to not waste our time. So question number 2.57 on same page 68. This question is also asked by one student, and I hope that is only fearing by seeming the question. It seems that it is very difficult, but only written lengthy. Its solution is looking very simple, and the question is dual behavior of matter proposed by de Broglie electron is this one. So if the velocity of the electron in the microscope is 1.6, calculate the de Broglie wavelength. Okay, so given that children, you have to solve try to solve almost all the numericals, and numericals makes your concept clear. So must do. If not, then if you are not in position to solve, then without any hesitation, without any difficulty, contact me. So according to question, the velocity is given. V is 1.6 into 10 to the power 6 meter per second. Then calculate the de Broglie wavelength associated with this electron. Okay, similar question. Lambda is asking, and moving particle is electron. So mass will be as usual 9.1 into 10 to the power minus 31 kilogram. Must use the proper unit. So add the formula lambda h by mb, h knowing 6.6, 10 to the power minus 34 divided by 9.1, 10 to the power minus 31. V is given 1.6 into 10 to the power 6. So children, 10 to the power minus 31 and 10 to the power plus 6 become 10 to the power minus 25. Am I right? And this 10 to the power minus 25 when go in numerator, this can be written as, simply this can be written as 6.6 divided by 9.1 into 1.6 into 10 to the power minus 34, and this is coming 10 to the power minus 25 when go in numerator become plus 25. Can be written, student? Alright. So on solving, this 25 and 34 become 10 to the power minus 9. Okay? And this on solving, perhaps the value will come 0.55 into 10 to the power minus 9, and that is coming in meters. 0.55 into 10 to the power minus 9 meters. And if the question is coming, you have to reply answer of this wavelength in nanometer. So you are knowing 10 to the power minus 9 meter is 1 nanometer. So that can be written as 0.45 nanometer. But more accurately, this can be written as 455 into 10 to the power minus 3. This is 0.445. So children, that can be written as, can be written. Okay. So I into already given 10 to the power minus 9. So minus 9 and minus 3, 10 to the power minus 12. So that become 455 into 10 to the power minus 12 meter, and 10 to the power minus 12 meter is nothing, that is a 1 picometer. So this is 455 picometer will be the wavelength of moving electron. Alright children? So this will be the solution of this very question. These three questions were asked. And one more question I telling you yourself, that is question number 2.58. Similar, that is based on de Broglie principle. See just question number 2.58. Question number 2.58 on same page, and question is similar to electron diffraction. Neutron diffraction microscope is also used for the determination of the structure of molecules. Okay, if the wavelength used here, wavelength is given, lambda is 800 pm, and pm stand for not prime minister or not that is past meridian, that is just, that is unit of wavelength picometer. Okay children, alright. Then calculate the characteristic velocity. The question is asking velocity. Question number 59. No. Question number 58, 59, yes, right. The velocity of the Bohr's orbit, Bohr's orbit, children. Question number 2.58, just I have described, not described. Okay, 58, alright. Okay, lambda is given 800 pm. Then what is the velocity? Velocity is asking. So V is asking, and one more thing of this question is neutron. Okay, you are knowing the mass of neutron. Mass of neutron is what children? 1.675 into 10 to the power minus 24 gram. Just convert it into kilogram. So just multiply by 10 to the power minus 3. So it will become perhaps 10 to the power minus 27 kilogram. Is it right? Now use the formula lambda h by m into v, or v is equal to h upon lambda into m. Can be written, children? Lambda is h by m, so v will be h upon lambda into m. Putting the value 6.6, 10 to the power minus 34, lambda is 800 pm. So that can be written as 800 into 10 to the power minus 12 meter. Can be written? Similarly, this 800 is become 8 into 10 to the power 2 into 10 to the power minus 12. Can be written? Children, am I right? This 800 can be written as, so this become what? This become 8 into 10 to the power minus 10 meter. Am I right? Okay, so put these values. So lambda become 8.0 into 10 to the power minus 10, and mass of the neutron here. You have to not use mass of electron. Question is mass of the neutron. So 1.67 into 10 to the power minus 27. So this minus 10 and minus 27 become minus 37, and when we go in the numerator become what? 6.6 upon 8.0 into 1.67 into 10 to the power minus 34 and plus 37. Minus 27 plus 10, 37, and this is minus 34 plus 37 is what? That is 10 to the power 3. 6.6 upon 8.0 into 1.67 into 10 to the power 3. Minus 34 plus 37 is 10 to the power 3, and that will come nearly on solving. The probable value may be 0.494 into 10 to the power 3 meter per second, or children, if you multiply this 0.494 into 10 to the power 3 become 494 meter per second. This may be the probable answer of this very question. Alright, one thing, student, one question that is also given very good, that is on page number 65, 2.7. Must do by yourself. One question is given that it looks like very simple, but always it comes. Wave number, and wave number you are knowing that just reciprocal of wavelength. Reciprocal of wavelength is called wave number. This is wavelength, and reciprocal of wavelength represented as nu bar is 1 by lambda is known as wave number. So solve it. If not comes, ask me. So that's all today. In upcoming lecture we will study a new topic. Till then, remember it. Have a good day. Be safe.